Okay, let's go through this practice test. This is test 4, so everything is means. There's no success, there's no failure, no P's, no Q's, everything is means here. Okay, so pause the video and read the problem. Okay, the first thing we want to do on every one of these is define our variable. What is it we're even trying to make predictions about? That's always going to be a mu. On every one of these, we're going to say mu. No P's or Q's. So here, let mu be the mean. What are we talking about? Claim amount. In dollars. Okay, we thought our null hypothesis is we thought the mean claim amount was $1,800. Our alternative hypothesis, what we're testing that against, is that no, it's actually more than $1,800. We know that we're doing a hypothesis test for 3 reasons. First, they say the word test. They give us a significance level. I mean, literally, it says right here, hypotheses. And they don't say the words confidence interval. Confidence intervals will always say construct a 95% confidence interval or whatever. We know we're doing a 1 sample hypothesis test because first off, we only have 1 group. We've only got 1 sample right there. There's our sample. We're not comparing 2 different groups. They only give us 1 standard deviation. That's the main clue. How many standard deviations do they give you? They only give us 1. So this is a t-test. I think that's button 2 on the calculator. So here are my sample stats. They're always going to give you all 3 of these, X bar, S, and N. X bar is the sample mean, $1,950. Sample standard deviation was $500. And my sample size was 40. Notice, by the way, here I said they're afraid the average claim is more than 1,800. That's what my sample says. It's also more than 1,800. And then we're going to draw a picture. This is a required step on these written assignments. Right in the middle, we've got mu equals 1,800. My sample mean is way up here, 1,950. And we're always going to shade a tail. We're always going to shade either a little tiny spot here or a spot here. So I'm going to shade this tail. Notice I shaded that direction. I shade it that way, which is the same thing I wrote there. The sample is bigger than 1,800. See, the sample's on the right. Okay, that's all my setup. Now my calculator does all the work. So I'm going to go into stat, over to tests, and down to number 2, a t-test. I don't know all the data. Sometimes, like in the homework, you'll have problems where they give you a bunch of data and you'll put that in L1 and you'll be done. Here, we know the sample statistics. Mu naught is this number here that's in your hypotheses. Notice these are both the same number. It's at 1,800. Then I put in my sample statistics. Then I tell it which hypothesis I'm choosing for the alternative hypothesis. I want mu is greater than mu naught. That's mu naught right there. So I want to make sure this one is highlighted. I hit calculate and I'm done. If the question asks you for the test statistic, that's your t-score right there. This question doesn't ask for it. We want the p-value, 0.032. So my p-value, 0.03. My alpha was 5%. That's less than alpha. Less than alpha, you always do the same thing. Reject the null, accept the alternative. Writing this statement is the second most important part of the problem. Like, this is your conclusion, right? We have to write this statement, reject the null and accept the alternative. Then the most important, what's that mean to accept the alternative? We got to write this out in words. So now we would say we have strong evidence. This is a required step. That, well, what's mu stand for? Oh, it's a good thing I wrote that down. The mean claim amount is more than 1,800. We don't know how much more, but they thought it was $1,800. They did a sample, and that sample says, oh, no, you're spending more than $1,800. All right, then I really like questions that have like a hidden question up here in the paragraph, and this one does. So we're trying to see, should this insurance company, should they be a little worried? They thought they were spending $1,800 per claim. This says, no, you guys are spending more than you thought. So yes, they should be concerned. So like here, that's my conclusion. This I could have written down here. But then I should follow up with that follow-up question. They should be concerned. All right, another question. Pause the video and read the question. Okay, we can see here this is going to be a one sample t-test. They say the words hypotheses. We know we're doing a hypothesis test. It does not say confidence interval. So it's either going to be a 1 or a 2 test. We got to figure out how many groups we have. Sometimes there are extra numbers floating around that confuse people. Look how many sample sizes you have. Look how many standard deviations you have. I only have one standard deviation. I only have one sample. This is a one sample test, or what your calculator calls a t-test. That's button number 2 on your calculator. First thing we have to do is define our variable. What is it we're trying to measure? Let mu be the mean. What are we talking about here? IQ. We write our hypotheses. So she thought her mean IQ at her school was 110. So mu equals 110. That's an equals there. Let me fix that. That looked like a not equal. But then she did a sample, and that sample says, no, it's not 110. It's less than 110. It's only 108. This one we're always going to write as equal. This one we're either going to write less than, greater than, or sometimes not equal to. Okay, we have our sample. They're always going to give you all 3 of these. And the calculator asks for all 3 of these. My sample mean, sample average was 108. The standard deviation was 6. And my sample size was 20. We draw a picture. That's a required step. Everything you see me writing is a required step on written assignments. Right in the middle is our mu naught. Remember, that's mu naught right there. 108 is below, less than 110. That's how I knew to write less than here, because 108 is smaller. Notice I also shade to the left. I'm shading that direction. Think of that like an arrow. I'm shading that way. That's the way this guy's pointing. All right, then the calculator does all the work. So stat over to test number 2. My mu naught was 110, 108, 6, 20, and I chose less than. I'm going to do this wrong. I want you to see something here. I chose the wrong alternative hypothesis here. If you get a p-value like 90%, you've done goofed. You've done something backwards. Your p-value will never be bigger than 50%. If this is bigger than 0.5, you've done goof somewhere. This is what I want here, less than, because see, I wrote less than right there. Calculate. Now I get a much smaller p-value. 0.0, we'll call that 0.76. My alpha level was 1%. That's a lot bigger than alpha. So I fail to reject the null. I don't draw any conclusions at all. This is a required step. You have to write this. This is important. What's that mean? We're always going to write this sentence right here in words. Always. We're either going to say we do or we do not have strong evidence to back this up. So here we would say we do not have strong evidence. We were not allowed to accept the alternative here. So we do not have strong evidence that the mean IQ is less than 110. And again, I did it again. The conclusions I could have written down here. Now, based on these results, there's this follow-up question here. I found this question online. I modified it a little bit, but this was the way the question was written when I found it online. And I kept this sentence here on purpose. The question says, should the principal accept or reject her original hypothesis? This was her hypothesis here. Should she reject it? No, we said right here, fail to reject. So she can't reject it. So a lot of times students will say, oh, well, then she must accept it. You never, ever accept a null hypothesis. That's not allowed. It's neither. She can't reject it because we failed to reject it. And you never, ever accept a null hypothesis. She can't do either of those things. So I'm going to write that. She should not accept or reject her original hypothesis. She failed to reject it. That's different than accepting it. She didn't prove it was false. That doesn't mean it's true. All right, this question here, pause the video and read the question. First thing we want to do, figure out what kind of problem we're doing. Is this a test or an interval? Well, it says the word hypothesis, gives us an alpha level, a level of significance, does not say confidence interval. So this is definitely a hypothesis test problem. Now, how many groups do I have? Now I've got two groups. I've got old batteries and new batteries. They give me two different sample means, two different standard deviations, two different sample sizes. This is a two sample t-test. Everything on test 4 here is going to be t's. And that's buttons 2, 4, 8, and 0 on your calculator. This is a 2-sample test, which I think is button 4. Right there, 2-sample t-test. Okay, first we define our variable. Let mu be the mean. What are we talking about here? How long the batteries run. Mean time these batteries run continuously. Okay, we're going to have 2 separate groups. We're going to have old and new. Each one's going to come with an X bar, an S, and an N. Let's see, the old batteries run for 190 minutes. Here, I could put in minutes. Standard deviation was 20. We had 100 of them. We had 100 of both. The new ones run a little longer, 200 minutes. Standard deviation of 40 minutes. My suggestion to you is whoever has the bigger sample mean, the bigger X bar, call them group 1. So I'm going to call these guys, the new ones, group 1, and these group 2. So number 1, number 2. Then your hypotheses are always the same. Mu1 minus mu2 equals 0. Sometimes we'll write that mu1 equals mu2, means the same thing. And then the alternative, mu1 minus mu2 is greater than 0. Or another way to write that, mu1 is bigger than mu2. So our null hypothesis is, these batteries are the same. There's not going to be any difference. There's no difference between them. The alternative is, no, the number 1, the new one, is better on average, lasts longer. All right, so we throw this in our calculator. Calculator does all the work. So I go to button 4, and I just type in my numbers, 190. Oh, and then I typed the wrong ones. Type in number 1, 200, 40, 100, 190, 20, 100. And I want mu1 is greater than mu2. We can always say pooled. No on pooled. Hit calculate. There's my t value. If a question asked you for the sample, the test statistic, that's your t value. I don't care about it. I want the p value. It's about 1%, 0.01. My alpha level is 5%. 1's less than 5. I'm less than the alpha. So I reject the null, accept the alternative. Less than alpha, reject the null, accept the alternative. Okay, now we can state our conclusions. What does that mean? That means we have strong evidence that this guy's average is bigger than this guy. And what are we talking about here? We're talking about means. You have to say the word mean in all your conclusions, mean or average. That the mean runtime for the new batteries is longer than the old. We look and see, are there any follow-up questions here. So the engineer's claim, what he's claiming is the alternative, that the new ones run better. So we've backed up his claim. I don't think we need to write anything else there. Okay, question 4 here. Read the question, pause and read it. First thing we want to do is figure out what kind of problem we're doing. This is a confidence interval. You know how I know that? It says confidence interval. How many groups do we have? Just one. They only give me one standard deviation. There are a bunch of numbers floating around. That right there, that number, that's just the population size. That's only there so we can check the conditions. That plays no role in the problem. Here's my sample. I got 150. That's my sample size. There's my sample mean and my sample standard deviation. Okay, first thing we want to do, define our variable. Let mu be the mean. What are we talking about here? IQ again. We have our sample. That's going to be an X bar, an S, and an N. 150 students. Mean IQ was 115 with the standard deviation of 10. Calculator's going to do all the work. Okay, so I want to go stat over to tests. T interval. Let me write that down. This is a T interval. That's button number 8. Remember, we're using 2, 4, 8, and 0. That's it on the calculator on test 4. And look, we just type in the 3 numbers we're given: 115, 10, 150. Well, the 4 numbers. Our confidence level is 99%, 0.99. We hit calculate and we're done. Did all the work for us. 112.87. Up to 117.13. Okay, now we write our sentence. We are 95% confident that we get so used to writing confidence intervals for proportions. A lot of times these get messed up. I'm not confident that between this and that, in the sense that these are not percentages. That's not 112% of something. These are mean IQs. We're 98% confident that the mean IQ is between those two numbers. And if we had units here, we'd have to make sure we put units. IQ, I mean, I could write IQ points, but we don't have units like dollars or inches or whatever. Okay, margin of error. The shortcut for margin of error, we could go through a whole bunch of math and find the margin of error, or we could just use margin of error is always high minus low all over 2. So a lot of mistakes happen here. People will type this. So they'll do high minus low divided by 2. They'll type it like this, and that's the wrong answer. It's not even close to the right answer. Remember what our confidence interval is. 115 is right in the middle of the interval. So we thought the mean IQ was 115, but we got to leave a little bit of wiggle room. I only went up 2 points above it and a little over 2 points below it. My margin of error is like 2 IQ points, not 60. When you're typing this in, you want to put that top in parentheses. parentheses, then divide by 2. Or, like, I'm too lazy to do that. I just type the top, hit enter, then take that answer and divide by 2. Either way, we get a margin of error of 2.13 IQ points. It's not percent. That's all over 2. And that was, I'll put it here, 2.13. All right, and then our last problem here. Again, pause the video, read the question. I hope you did that. We got to figure out what kind of problem we're dealing with. It's obviously a confidence interval because it says confidence interval. We got two different groups. We got school A and school B. They give me two different standard deviations. This is a 2-sample confidence interval. That's going to be button 0 on the calculator. So if we look here for the test, 2-sample T interval. All right, first thing we do is define our variable. Let mu be the mean. What are we talking about here? Score on the standardized test. All right, we have our two different groups. I'm going to need some space here. So we got A and B. Each group is going to come with an X bar, an S, and an N. Let's see, 15 from A, 20 from B. School A had an average of 1,000, with the standard deviation of 100. That's right there. These guys had an average of 950 and a standard deviation of 90. Whoever has the bigger sample mean, call them group 1. So these A is going to be 1. B is going to be 2. And you got to tell me this kind of stuff. On written assignments, you have to tell me who you're calling group 1 and group 2. All right, now we just throw this all in the calculator. It's going to do all the work for us. So button 0. I type my 6 numbers. My confidence level was 90%. I can always say no on pulled, hit calculate, and there's my interval. -5. .659, comma 105.66. So there's the interval. Now we got to figure out how to interpret that. So I'm going to have to come down here and write that. So it's always, we are, in this case, 90% confident that the average for group 1 is between this and that, higher than the average for group 2. What's it mean to be negative higher? It means lower. So we are 90% confident the mean test score at A is between, that means between 5.659 points lower, negative higher means lower, and 105.66 points higher. Than at B. That says than. So who wins? Who's Who's got the higher test average? We don't know. Anytime you have a negative and a positive in your interval, there's no winner. If these were both positive, then that would mean school A is the clear winner. We're really confident that they have a higher average. If you get two negatives, you chose the wrong group one. Start back over. If you get two negatives, you got group one and group two backwards. Okay, let's find our margin of error. We got to be careful here, especially when we got these negatives. High minus low, that's a negative, minus a negative. It's always high minus low, but the low was a negative number. So that's going to be 105.66 plus 5.659 over 2. Oh, no. 5.6, nope. 659. Do the top, hit enter, then divide by 2. Okay, something went wrong there. Let me type this real quick again. 5 plus 5.659 divided by, there we go, 2. So we get this big gigantic margin of error, 55.6545. It's not percent. We don't tack anything onto it. If we want units, it's the same units as our mean. So it would be IQ points or a test score. Okay, that's a good place to stop.